Okay, guys, we have 2021 paper 2 and organic chemistry C3, question C3. Okay, so this is section C, question 3 and 10 marks. So this is the reaction scheme that is here. Let me explain a few things as I'm explaining here. I'll be even answering some of the questions. So we have, this is the direction, we have ethene. When you add bromine water to ethene, the bromine water will be decolorized. So the color of bromine water is brown. When it's added to alkenes, the bromine water, the bromine solution loses its brown color. Okay? Now, what is the name of a liquid that is formed when bromine is added to ethene? So the name of the liquid that is formed is a little bit trick. Is 1,2-dibromo in, okay, 1,2, then you have hyphen here, dibromoethane. So the chemical formula for this one is, since this one is like is an additional reaction, the formula for ethane is C2H4. Then bromine exists as diatomic molecule, so it will attach itself like this, like this. So this is the formula for 1,2-dibromoethane. Okay, changes to ethane, not ethene. Then when you add gas A to ethene, it changes to ethane. This one is hydrogenation of ethene. Okay, when hydrogen is added, so this one, gas A, it has to be hydrogen gas. Okay, when ethane, when you add gas C and the condition D here, we form chloroethane. Chloroethane, it means that we have used chlorine. So gas here is chlorine. Okay? Then what is the condition involved here? It is sunlight. Okay? Sunlight, it is the condition, it is a catalyst, which is known as ultraviolet light. So okay, just a sunlight. Okay? Now when it comes down, when you come down here, ethane, when we add excess oxygen, this is burning, okay, or combustion. This is combustion. So in ethane combustion, this is excess oxygen. Excess oxygen means complete combustion, and it is carbon dioxide that is produced in complete combustion. Okay, when we add water to ethene, remember what I said in the other video, in the other question, when water is added to ethene, we form ethanol. But when water is removed, and this is called hydration. When water is removed from ethanol, the other way around, it's called dehydration. Let's now answer the questions that follow. Question A, identify gas A. Oh, gas A. What is A? So gas A is hydrogen gas. Number 2, gas B, carbon dioxide. Carbon dioxide. This would have been carbon monoxide if it was just limited oxygen, limited supply of oxygen. Now oxygen is in excess, it is carbon dioxide. Number 3, gas C. Where is C? Oh, gas C is chlorine. is chlorine gas. Then number four is condition D. Condition D is sunlight or ultraviolet light or sunlight. That is the catalyst used. That is number four. Number five, liquid E. Where is E? Liquid E is here, ethanol. Okay, ethanol. This is V6. 6 is liquid F. Liquid F is 1,2-dibromoethane. Okay, dibromoethane. Question B. Now question B, I need to create space. It's saying write a balanced chemical equation for the reaction of ethene with excess oxygen. This is a complete combustion, guys. Okay, a complete combustion. I can erase this. Let me create space here. So this is question what? This is B. Is complete combustion of ethene with excess. So the formula for ethene is C2H4 reacting with oxygen, complete combustion in carbon dioxide and steam, which is H2, like this. Balancing C2, C1. So when you put a 2 here, it will number of carbon atoms will balance. Hydrogen 4, hydrogen 2. When you put a 2 here as well, hydrogen atoms will balance. Oxygen 2 times 2, 4. 4 plus 2 times 1. So 4 plus 2, 6. We'll put a 3 here, balances. So this equation is balanced. We still have question, also have question C. So question C is saying, give the structure formula of liquid E. Liquid E, ethanol. They need the structure formula of ethanol. Okay, structure formula of ethanol. Now, first, the molecular formula is C2H5OH. So the structure formula will be C to C of 2 carbon atoms, OH to H here, another hydrogen atom, hydrogen atom, hydrogen atom. That's it. This is the answer to question what? Question C. Question C. Then the last question is saying state the industrial application of the reaction of ethene with gas A. Ethene with gas A to form ethane. State the industrial application, meaning hydrogenation. So industrial, so you can say the reaction of ethene and hydrogen is used during hydrogenation okay, during hydrogenation, which is used in the hydrogenation of vegetable. Oh, okay, let me just see. unsaturated in the hydrogenation of vegetable oil, okay, which is the vegetable oil which is used in the manufacture of margarine. Okay, so the reaction of ethene and hydrogen is called hydrogenation. So it's used during the hydrogenation of vegetable oil, which is used in the manufacture of, in the making of margarine. Okay, so that's all to question C3 of 2021 paper 2. Okay guys, we have 2021 paper 2. We are still looking at organic chemistry. Okay, so the question B8, this is internal 2022, and the question reads, the structures below shown below are members of one of the homologous series in organic chemistry. Okay, so they all belong to one family. Okay, what the first question is saying, give the general formula for this homologous series. The general formula for all of these. Now, how can you know the general formula? Listen, these are not hydrocarbons because they contain oxygen, there's oxygen here. And you can't see a double bond here, a carboxyl group. We can't see a double bond. We can see hydroxyl group, OH, OH, OH. So these are alkanols or alcohols. Okay, and the general formula for all alcohols is CnH2n plus 1, okay, then OH, which is the hydroxyl group. So CnH2n plus 1 OH. This is the general formula for all alcohols. Question B. What is the functional group for the homologous series? For the homologous series, it's simple. So the functional group is called hydroxyl group. Okay, hydroxyl group, which is like this. This one, OH, is called hydroxyl group. C, S is used as a fuel because it burns in oxygen. Wow. Write a balanced chemical equation for this reaction. So this is the complete combustion. And if you look at this is ethanol, guys. This is ethanol. It's C2H1, 2, 3, 4, 5. Then what? OH. This is ethanol. So like in the previous video, we answered the complete combustion of this. So ethanol, we are asked to write the balanced chemical equation, which is C2H5OH, or oxygen combustion, remember? So the complete combustion, what will be produced here is carbon dioxide and water. Carbon dioxide and water. And balancing this equation, you have 2 atoms of carbon this side. This side we have 1. So we're going to write a 2 here. So use a different color. Write a 2 here so that the carbon atoms balance. Hydrogen you have 6. Hydrogen you have 3 here. Or we have 2, sorry. So we'll put a 3 so that also hydrogen atoms balances. The other one is after hydrogen there's oxygen. Oxygen here you have 6. And oxygen here 2 times 2, 4. Plus this 3, 7. So how can we make this 7? By introducing a 3 here, because 3 times 2 is 6 plus 1, 7. So this is the answer. Wow. The last question on question B8, which is D, is saying, Which of the compounds R, S, or T would have the highest boiling point? This question they usually ask. So the answer is T. Okay? So D, so compound T. If the question was, if they even said, give a reason for answer, because compound T has the highest number of carbon atoms. 1, 2, 3, this is 2, this is 1. So compound T has the highest boiling point. So compound T has the highest boiling point. Okay. So guys, in the previous video we answered question B9 under organic chemistry, and so it was about the processes that are involved when ethanol is oxidized. Ethanol is when you remove water from ethanol, which is dehydration, when ethanol undergoes complete combustion. So I mentioned that the only process that was missing was fermentation of fermentation. Okay, now here is the question under fermentation. Ethanol is a product of many fermentation reactions. The molecular formula of ethanol is C2H5OH. Okay? Draw, first question, this is question A. Draw the displayed molecular structure of ethanol. The molecular structure, this one is the formula, molecular formula C2H5OH of ethanol. The structure formula, you always start with the carbon atoms, and if it's a single, C2C. Then this side, you add this hydroxyl. OH is not hydroxide here, it is called hydroxyl group. This is the functional group for all alkanols or alcohols. So we have hydrogen here, hydrogen here, hydrogen here, hydrogen here, and hydrogen here. So they completely surround the number of carbon atoms. So we have 1, 2, 3, 4, 5, 6, numbers of hydrogen atoms. So this one is not a hydrocarbon because there is oxygen. Okay? Let's go to B. So question B is saying, when ethanol is heated with potassium dichromate 5, it is converted to ethanoic acid. Yeah, true. So, listen, ethanol undergoes oxidation. The first one, oxidation, you form ethanoic acid, and also when you use potassium dichromate 6, not 7, 6, you also form ethanoic acid. So what they're saying is, what type of reaction is this? This is the oxidation reaction. Okay, oxidation reaction. Number 2, B2. Give one safety rule to be observed when handling ethanoic acid. Give one safety rule when handling ethanoic acid in the lab. So one of the safety rules is that where appropriate safety gear. Okay, so where appropriate safety gear, such as gloves, goggles, all right, and others. So wear appropriate safety gear. That is the safety rule you can observe when handling with ethanoic acid in the lab. Okay, question C. So question C is saying ethanoic acid reacts with ethanol in the presence of a catalyst. To produce a new substance. Give the name and deduce the formula of a new substance. Guys, if this ethanol reacts with ethanoic acid, the product will be an ester, and the reaction is called esterification reaction. Okay, esterification reaction. So the product will be, since you have ethanol and ethanoic acid. So the name of an ester. So since this reaction is called esterification, when an alcohol reacts with a carboxylic acid, this is called esterification. So the name of a compound that will be formed starts with the name of the alcohol. So it will be ethyl, then this one ether, ethyl ether, ethanoate. So they end with the noate, the esters. So it will be ethyl ethanoate. Why? Ethyl from an alcohol, then the last party from a carboxylic acid. So if here we use methanol, it will be methyl ethanoate. If you use propanol, ethanoate. Okay, simple as that. Now, what is the chemical formula? What is the formula formed for ethyl ethanoate? Okay, ethyl ethanoate, water is removed during this reaction. So the formula that will be formed for ethyl ethanoate, since ethanol is C2H5OH, then for this ethanoic acid is CH3COOH. Okay, CH3COOH. Then water is formed. Water is removed. So carboxylic acid loses the OH, and this one the H. So when combining, let me just mention this so that it helps you in the exam. Just remove the hydroxyl group here, and from here just remove the H to form water. So when this and this one react, what will be formed is will form water, and just join what is remaining. Let's start with the acid, which is CH3COC2H5. So this one is for carboxylic acid, and this one is for the alcohol. So this is the formula, which is further simplified as how many carbon atoms do you have here? When you look nicely, you have 1, 2, 3, 4. Since we have 2 here, 2, 3, 4. So the formula for ethyl ethanoate can be C4. How many hydrogen atoms? You have 3. 3 plus 5, 8. So it can be C4H8, or how many oxygen? 2. So C4H8O2 as the simplified formula for ethyl ethanoate. Okay, so this is the name and this is the formula, or this one. Simple. Next question is Compare the rate of reaction of ethanol, what's this? Ethanoic acid, okay. Ethanoic acid is a weak acid. It can react with a metal such as sodium and magnesium. So you have acid, which is just a weak acid. So an acid and a metal. That's the key. The products are a salt and hydrogen gas. A salt and hydrogen gas. Now, what are they asking? They're saying compare the rate of reaction of ethanol with sodium and with magnesium. So what you can say is, since this is question what? D1. So with sodium, ethanol will react vigorously with water. Okay? Vigorously with water. While or than with that is, this is potassium, magnesium, than with magnesium. Okay? So this is very simple. The reason is like this, is like this. Magnesium, ethanol will react vigorously with not with water, sorry, with sodium. With sodium producing hydrogen gas here and the salt than with magnesium. The reason is very simple. The reason is sodium is more reactive than magnesium. If you place them in the reactivity series of metal, sodium is above magnesium. So the reaction of this acid with sodium will be more vigorous than with magnesium. Okay, than with magnesium. Then second question is, what will be observed when aluminum is added to ethanoic acid? Give a reason for this observation. When aluminum is added to ethanoic acid, so when aluminum is added to ethanoic acid, the product will be, or let me just say, let's just say, so we can say a lot of observations and what will happen. What we can say, bubbles will be observed. Bubbles will be observed as hydrogen gas is produced. Okay, then The other product will be, since we've used aluminum and ethanol, it will be aluminum. So the other product will be aluminum. We've used ethanoic acid, so it will be ethanoate. Aluminum ethanoate as will be the salt in this case as our salt. Then the other product will be hydrogen gas. Okay. Then the other question is give one use. This is 3. Give one use of aluminium based on the observation made in D. Aluminium ethanoate. So aluminium ethanoate, the observation here, aluminium ethanoate is used in the manufacture of antiperspirant. Okay, antiperspirant. Now, antiperspirant, this is a product that is applied to the skin, usually under the arms, to prevent perspiration. Perspiration, which is sweating or producing a bad odor. So, this is an antiperspirant. So aluminum ethanoate is used as more like a deodorant to prevent a bad odor. So, and it is used in the manufacture of antiperspirant. Okay, so it is used in the manufacture of, so you can say it is used in the manufacture of, based on the observation here. There are a lot of uses of aluminum, but here they've said the usage should be based on the observation we've made. Okay, so it is due to the manufacture of antiperspirant. Okay. That's it. Do you have another question? No, that's it. So these are the solutions to question C3. Okay. So guys, in the previous video, we answered question B9 under organic chemistry, and so it was about the processes that are involved when ethanol is oxidized. Ethanol is when you remove water from ethanol, which is dehydration, when ethanol undergoes complete combustion. So I mentioned that the only process that was missing was fermentation of fermentation. Okay, now here is the question under fermentation. Ethanol is a product of many fermentation reactions. The molecular formula of ethanol is C2H5OH. Okay? Draw, first question, which is question A. Draw the displayed molecular structure of ethanol. The molecular structure, this one is the formula, molecular formula C2H5OH of ethanol. The structure formula, you always start with the carbon atoms, and if it's a single, C2C. Then this side, you add this hydroxyl. OH is not hydroxide here, it is called hydroxyl group. This is the functional group for all alcohol. or alkanols or alcohols. So we have hydrogen here, hydrogen here, hydrogen here, hydrogen here, and hydrogen here. So they completely surround the number of carbon atoms. So we have 1, 2, 3, 4, 5, 6, six numbers of hydrogen atoms. So this one is not a hydrocarbon because there is oxygen. Okay, let's go to B. So question B is saying, when ethanol is heated with potassium dichromate 5, it is converted to ethanoic acid. Yeah, true. So, listen, ethanol undergoes oxidation. The first one, oxidation, you form ethanoic acid, and also when you use potassium dichromate 6, not 7, 6, you also form ethanoic acid. So what they're saying is, what type of reaction is this? This is the oxidation reaction. Okay, oxidation reaction. Number 2, B2. Give one safety rule to be observed when handling ethanoic acid. Give one safety rule when handling ethanoic acid in the lab. So one of the safety rules is that where appropriate safety gear. Okay, so where appropriate safety gear, such as gloves, goggles, all right, and others. So where appropriate safety gear, that is the safety rule you can observe when handling with ethanoic acid in the lab. Okay, question C. So question C is saying, ethanoic acid reacts with ethanol in the presence of a catalyst. To produce a new substance. Give the name and deduce the formula of a new substance. Guys, if this ethanol reacts with ethanoic acid, the product will be an ester, and the reaction is called esterification reaction. Okay, esterification reaction. So the product will be, since you have ethanol and ethanoic acid. So the name of an ester. So since this reaction is called esterification, when an alcohol reacts with a carboxylic acid, this is called esterification. So the name of a compound that will be formed starts with the name of the alcohol. So it will be ethyl, then this one ether, ethyl ether, ethanoate. So they end with the noate, the esters. So it will be ethyl ethanoate. Why? Ethyl from an alcohol, then the last party from a carboxylic acid. So if here we use methanol, it will be methyl ethanoate. If you use propanol, ethanoate. Okay, it's simple as that. Now, what is the chemical formula? What is the formula formed for ethyl ethanoate? Okay, ethyl ethanoate, water is removed during this reaction. So So the formula that will be formed for ethyl ethanoate, since ethanol is C2H5OH, then for this ethanoic acid is CH3COOH. Okay, CH3COOH. Then water is formed. Water is removed. So carboxylic acid loses the OH and this one the H. So when combining, let me just mention this so that it helps you in the exam. Just remove the hydroxyl group here, and from here just remove the H to form water. So when this and this one react, what will be formed is will form water, and just join what is remaining. Let's start with the acid, which is CH3COOC2H5. So this one is for carboxylic acid, and this one is for the alcohol. So this is the formula, which is further simplified as how many carbon atoms do you have here? When you look nicely, you have 1, 2, 3, 4. Since we have 2 here, 2, 3, 4. So the formula for ethyl ethanoate can be C4. How many hydrogen atoms? You have 3. 3 plus 5, 8. So it can be C4H8, or how many oxygen? 2. So C4H8O2 as the simplified formula for ethyl ethanoate. Okay, so this is the name and this is the formula, or this one. Simple. Next question is compare the rate of reaction of ethanol, what's this? Ethanoic acid, okay. Ethanoic acid is a weak acid. It can react with a metal such as sodium and magnesium. So you have acid, which is just a weak acid. So an acid and a metal. That's the key. The products are a salt and hydrogen gas. A salt and hydrogen gas. Now, what are they asking? They're saying compare the rate of reaction of ethanol with sodium and with magnesium. So what you can say is, since this is question what? D1. So with sodium, ethanol will react vigorously with water. Okay, vigorously with water. Wow. Or than with that is, this is potassium, magnesium, than with magnesium. Okay, so this is very simple. The reason is like this, is like this. Magnesium, ethanol will react vigorously with not with water, sorry, with sodium. With sodium, producing hydrogen gas here and the salt than with magnesium. The reason is very simple. The reason is sodium is more reactive than magnesium. If you place them in the reactivity series of metal, sodium is above magnesium. So the reaction of this acid with sodium will be more vigorous than with magnesium. Okay, than with magnesium. Then second question is what will be observed when aluminum is added to ethanoic acid? Give a reason for this observation. When aluminum is added to ethanoic acid, so when aluminum is added to ethanoic acid, the product will be, or let me just say, let's just say, so we can say a lot of observations and what will happen. What we can say, bubbles will be observed. Bubbles will be observed as hydrogen gas is produced. Okay, then the other product will be, since we've used aluminum and ethanol, it will be aluminum. So the other product will be aluminum. We've used ethanoic acid, so it will be ethanoate. Aluminum ethanoate as will be the salt in this case as our salt. Then the other product will be hydrogen gas. Okay. Then the other question is give one use. This is 3. Give one use of aluminum based on the observation made in D. Aluminum ethanoate. So aluminum ethanoate, the observation here, aluminum ethanoate is used in the manufacture of antiperspirant. Okay, antiperspirant. Now, antiperspirant, this is a product that is applied to the skin, usually under the arms, to prevent perspiration. Perspiration, which is sweating or producing a bad odor. So, this is an antiperspirant. So, aluminum ethanoate is used as more like a deodorant to prevent a bad odor. So, and it is used in the manufacture of antiperspirant. Okay, so it is used in the manufacture of, so you can say it is used in the manufacture of, based on the observation here. There are a lot of uses of aluminum, but here they've said the usage should be based on the observation we've made. Okay, so it is due to the manufacture of anti-perspirant. Okay, that's it. Do you have another question? No, that's it. So these are the solutions to question C3. Okay. Question B8 of 2022 Science Paper 2 GCE under Organic Chemistry is saying, so we've been given 4 hydrocarbons. The first one is CH4, C4H10, C6H14, C10H22, H22. Then the 4 hydrocarbons given are members of the homologous series. So they belong to a same family. Okay? They belong to the same family. Now, the first question is, explain the term hydrocarbon. So, hydrocarbon, this is simple. From the word hydro and carbon, meaning it's made up of hydrogen and carbon. So hydrocarbon is a compound, an organic compound. Organic is an organic compound that contains carbon and hydrogen only. Okay, so if you look at these compounds here, there is carbon, hydrogen, carbon, hydrogen, carbon, hydrogen, carbon, hydrogen. There is no oxygen or any other element. So these are hydrocarbons. So a hydrocarbon is simply, or hydrocarbons are simply organic compounds that are made up of carbon and hydrogen atoms only. Question B. There are 2 questions under question B. So question B1 is saying, name the homologous series to which the above hydrocarbons belong. Name the family to which these belong. How do we know the family to which these belong? Remember, the first family are alkanes. Now, the only way we can know is using the general formula. The general formula for alkanes is CnH2n plus 2, where n starts from 1. So alkanes, so if we substitute 1, we're going to have H4, which is this C1H4, and 1 is invisible. So this one is working. Let's use 4. If you substitute 4, here to be 4 times 2, 8 plus 2, 10. C4H10 is working. Let's use this one. If you substitute N for a number of carbon atoms, 10, it will be C10, 2 times 10, 20 plus 2, 22 is working. So these are alkanes. That's it. Number two. Compound. Name the compound with the molecular formula C4. H10. C4 is bute. And since these are alkanes, and alkanes they end with ANE, so this one is butane. Like this. Okay? Butane. Number C, question C. Draw the full structural formula of the hydrocarbon which has 4 carbon atoms. Which is this one? Butane. C4H10. And so this one is not the structural formula, this is the molecular formula. We are asked to draw the structural formula. Alkanes, the number of carbon atoms are surrounded by hydrogen, are completely surrounded by hydrogen. That's why they're called they are also called saturated hydrocarbons. So since we have 4 hydrogen atoms, carbon atoms, it will be C to C to C to C. This is single bond. Alkanes are single bond. Hydrogen here. So this is where hydrogen atoms will be. Okay? And you have 10 of them. So you have 1, 2, 3. You can start with any 4 as long as they'll fit. From this 8, 9, 10. This is the structure formula for butane. Okay? Or an hydrocarbon with 4 carbon atoms. 4 carbon atoms. So that is the answer. Oh, there is another one, which is question, I think it can fit here. Which of the given hydrocarbons has the highest boiling point? So C, D here. Which of these has a highest boiling point? The answer is the one with the highest number of carbon atoms. This one has 1, this one has 4, this one has 6, this one has 10. So it is C, this one C10, H22, which is decane. The reason why decane here, this one has the highest number, as the highest boiling point, is because the boiling point of alkanes increases as the number of carbon atoms increases. So this one has the highest boiling point. That's all. That's the answer to question B8 of 2022 GCE paper 2, which is science. Thank you so much. Remember to subscribe, like the video, and also to leave a comment in the comment section. This is the only way you can help the channel be recommended to others as well, and also help it to grow. Thank you so much. Okay, so we are given grade 12 science paper 2 2020. This is internal or October-November exam. We are answering organic chemistry questions in this series of tutorials. So question B8, meaning section B, 9. Section B, question 9, the question reads, the following diagram shows some of the reactions of ethanol. Some of the reactions of ethanol. Okay? Some of the reactions of ethanol. So, ethanol here, there is oxidation here. It's another, it's written oxidation here. That's another process. So when ethanol is oxidized, what is solution P? When ethanol produces ethene, what is the name of the process? When ethanol undergoes complete combustion, what are the products? This is nice. Okay, so before we go to the questions, let me just make mention of this. When ethanol is oxidized, ethanol undergoes oxidation to form ethanoic acid. Okay, to form ethanoic acid. All right, to form ethanoic acid. So ethanol during the fermentation, oxygen should not be allowed during the reaction chamber. Oxygen should not be allowed. Why? Because when oxygen is allowed to ethanol immediately tends to ethanoic acid. All right, tends to ethanoic acid. Then ethanol can also undergo hydration. When you add water to ethanol, dehydration, sorry. Dehydration. When you remove water from ethanol, you form ethene. Okay? When your water is removed from ethanol, you form ethene. Now, when water is added to ethene, you form ethanol. So from ethene to ethanol is excuse me. Is hydration, sorry. Is hydration. Now, when water is removed from ethanol is dehydration. So this process from ethanol to ethene is dehydration. Okay? Now, ethanol can also undergo combustion. Okay? Ethanol can also undergo combustion. So complete combustion. So complete combustion of anything, complete combustion, what are the products are carbon dioxide and water. Carbon dioxide and water. So this is to summarize the processes that the reactions of ethanol. There is only one reaction that is missing here, which is fermentation. I think we'll answer it in the next video, okay, where we are supposed to use fermentation, glucose, to come up with ethanol. Now, let's go through the questions. So you will notice that we've answered most of the questions when you go through the questions. Question A is saying, draw the structure formula of ethene. Now, ethene, the chemical formula, not the chemical formula, the molecular formula is C2H4. So the structure formula of ethene, since ethene is ends with ENE, it's an alkene. So it has a double bond between two carbon atoms. So C to C, like this. Then you have hydrogen here, hydrogen here, hydrogen on top, hydrogen on top, like this. Okay, you have double bond here. So this is the structure formula for ethene. Question B. Question B. I hope it's visible. Yes. So if it is not visible, you can change the resolution of the video quality. I think all the videos on this channel are 1080p. Some are in 1440p and others in 4K, but we usually use 1080p. So you can change the resolution to 720p, okay, so that you can see what is here. Okay, so this is the structure formula for ethene. Then the second question is saying, which is question B, give the names for one, solution P. Solution P is ethanoic acid. So ethanoic acid. Okay, when ethanol is oxidized, when oxygen is added to ethanol, ethanoic acid is formed. Number two, they're saying give the name of Process Q. Yes. So this is dehydration. When water is removed from ethanol, you form ethene. Okay? Ethene and steam. So the process is called dehydration. Then gas R here is carbon dioxide. So question 3 is carbon dioxide. Okay, carbon dioxide with the formula CO2. Then the last question, which is question C. Let me create space here. The last question, which is question C, saying write a balanced chemical equation for the complete combustion of ethanol. So the chemical formula for ethanol is C2H5OH. So combustion, you react with oxygen, all right, to form carbon dioxide and water. So balancing this will be, you have 2 atoms of carbon this side, you have 1. So you can put a 2 here so that the carbon atoms balance. We have 6 atoms of hydrogen this side, there are 5 plus this one, 6, and this side we have 2. So you can put a 3 here, which when we multiply it with 2 becomes 6. Okay? Oxygen, this side you have 2 plus, or 1 plus 2, 3. So on the reactant side you have 3. Then on the product side we have 2 times 2, 4. 3 times 1, 3, so 4 plus 3, which is 7. Then this side you have 3. So if we put a 3 here, it will be 3 times 2, 6, plus 1, 7. So our combustion reaction, chemical reaction or chemical equation has balanced. Do you have another question? That's all. That's all to this question. All right. It is as simple as that. So let's go to the next question, which is section C. Question what? Question C3. Okay, which is 10 marks. Guys, let's revise on polymers using this question, examination question. Then the question reads, the table below shows the structural formulae of various monomers and the polymers that can be made from them. So you can see the table, you have the monomer, you have ethene, tetrafluoroethene, and then we have W there. Polymer, we have polyethene, polytetrafluoroethene, and then we have Y. Then they're saying identify the monomers which are hydrocarbons. This is good. Identify the monomers which are hydrocarbons. So the monomers hydrocarbons are, these are compounds made up of hydrocarbon and hydrogen only. So when you look at the monomer ethene, there is carbon and hydrogen only. So you can say the first one is ethene. The second one is, look at tetrafluoroethene, there is fluorine. Then the W, there is C and H only. So you can say and W. Since they have not told us to name what W is, so you can just say W is a hydrocarbon, because there is only carbon. When you look at it, there's only carbon and hydrogen. Okay, question B. Name the monomer W. How can you know that this is this monomer? Remember that these are additional polymers, okay, and we always use alkenes or unsaturated hydrocarbons. So how can you know that this monomer is this or this? Let me show you something. So look at the structure. You have a double bond here, so it ends with the ENE. Then how many carbon atoms do we have? We have 1, 2, 3. When you have 3 carbon atoms, then hydrogen atoms, you have 6. So C3H6, this is propene. Okay, this is propene. So you can say this is propene. Okay, it's propene. Then C is saying draw the displayed structure for polymer Y. The displayed structure of polymer Y, what you need to do is you just draw this the way it is, but as a single bond. You just say carbon to carbon. Then you have hydrogen here, and here you have the CH3. Okay, the way it is. Here you have H. Here you also have H. This single bond makes it possible here for other monomers to join, even this side to join. Then write it like this, then put N. This N represents number of monomers, like the way others are for polymer polyethylene and polytetrafluoroethene. Okay, and polytetrafluoroethene. So this is the answer. Let's go to question D. We are still under organic chemistry, if I'm not mistaken. Yes, we are still under organic chemistry. So D is saying D1. Identify the common feature among the monomers in the table. Wow. So the common feature, when you look at the common feature, they all have the double bond. So you can say they all have the double carbon to carbon bond. Okay? They all have double carbon to carbon bond, which is this one. The second one. Give the name of the compound with this feature. The name of the compounds with this feature, or the family with this feature, double bond, or the homologous series with this compound are alkenes. Alkenes. That is D. Decane can be cracked to produce hexane and butene. Explain the meaning of the word cracking. The word cracking. So they are just asking us to define cracking of hydrocarbons. So you can define cracking as cracking is the breaking down of large hydrocarbons. Large is the breaking down of large. This is N. The breaking down of large hydrocarbons. When I say hydrocarbons, I mean compounds containing hydrogen and carbon. Hydrocarbon, carbon molecules into simpler molecules, into simpler, just write nicely, into simpler and smaller molecules. And just an additional information, just a bonus to you, just to know that there are two types of cracking. There is thermal cracking, where you use heat, thermal cracking, and there is also catalytic cracking. Cracking, where you use a catalyst. Okay, these are the two types of cracking. Those are the answers to this question. Let's look at another organic chemistry. Oh, there is another question. Oh, that's all. 7 marks. So let's look at another examination question. So these were the answers to this question. Let's go to another question. Good morning, good afternoon, good evening, whenever and wherever you're watching this video from. In this video, we are going to look at chemistry, specifically organic chemistry, grade 12, science paper 2, 2022 GCE, question 3. Okay, question 3. So we are going to start with the first question, which is saying, so the first statement says, propene is one of the many important hydrocarbons obtained from crude oil, like propane. Okay, let me just write the way, both of them, propene and propane. It is made up of molecules which contain 3 carbon atoms. The first question, which is question A, 1, draw the structure formula for propene. Now, how do you draw the structure formula for propene? First, you come up with the molecular formula for propene. Propene, since they end with you need to know the general formula for propene. Since they end with ANE, meaning they come from the family of alkenes. Okay, alkenes, and the general formula for alkenes is CnH2n, where N starts from 2. Okay, so the first element has 2, so it will be C2H2 times N, which is 2, 4, and this is ethene. So a hydrocarbon with 2 carbons, with 2 carbon atoms, is eth. With 3 is prop. So if you substitute 3 here, it will be 2 times 3, which is 6. And so this one is propene. So if the molecular formula is C3H6, then the structure formula will be, since this one is a hydrocarbon and it has a double bond, you always start with a double bond, C to C. Okay, C to C. Then where do you put another C? It's a single bond, which is this side. Okay, then you have hydrogen here, 1, hydrogen 2, hydrogen 3, hydrogen 4, then hydrogen 5, hydrogen 6. So this is the structure formula. If you've noticed, this side we don't have we don't have hydrogen. Even this side we don't have hydrogen. So that's what makes this unsaturated hydrocarbon because of double bond here and the number of hydrogen atoms, they don't completely surround the carbon atom. So this is the structure formula. Next question, which is question 2. How does propene differ from propane in terms of bond? How does propene differ from propane in terms of bond? Listen, in terms of bond, propene has double bond, propane has single bond. So we can say propene has a double carbon to carbon bond, while propane has a single carbon to carbon bond. By the way, this is carbon C to C, carbon to carbon bond. That is the difference. Question 3. Question 3 says, to which group of hydrocarbons does propene belong? Okay, to which, let me just create space. To which group of hydrocarbons does propene belong? Remember what I said, that propene, because it's ending with ENE, these are alkenes. So hydrocarbons, the answer there is alkenes. Number 4. Number 4 says, give the molecular formula for the propane and propene respectively. The molecular formula for propane and propene. So, molecular formula for propane, since it ends with ANE, these are alkenes. Alkanes, sorry. These are alkanes, and the general formula is CN H2N plus 2, where N starts from 1, number of hydrogen carbon atoms starting from 1, 2, 3, going up like that. So the first one is meth, so it becomes methane. Second one is eth, which is ethane. The third one is prop, which is propane, is this one. So if we substitute 3 here, it will be C3 H2 times 3 plus 2, which therefore gives us the formula C3, 2 times 3 is 6 plus 2, 8. C3H8 for propane. Then for propene, I wrote the formula for propene, which is C3, number of hydrogen carbon, just the same as propane, but the number of carbon atoms just the same as propane. Then only the hydrogen atoms, here it is 6. These are molecular formula or formulae of the two. We still have more questions. So the other question is saying, Um, Propene is obtained by breaking down longer chains of hydrocarbon. Longer chains of hydrocarbon. What is this process called? This is C. What is the process of called when a hydrocarbon is broken down to smaller or simpler molecules? It is called cracking. Simple. It is called cracking. Question D. This is C. Question D. D is saying D1. Explain why propene reacts immediately with bromine water, whereas propane does not. So, the answer is very simple. Propene reacts with bromine water because it is an unsaturated hydrocarbon while propane is a saturated hydrocarbon. That's the issue. And the results will be when propene reacts with bromine water, the color of bromine water, which is reddish brown, will change to colorless, signifying that the reactant or the substance is an alkene. So alkenes, they decolorize the bromine water. Meanwhile, alkanes, they don't. Okay? That's the answer. Question 2. Question 2. Describe what will be observed during the reaction. Oh, wow. This is what I'm from explaining. Propene will decolorize bromine water. While propane will not. Okay? So we'll decolorize. When propane or alkanes, any alkane react with bromine water, the color of bromine water will never change, will not change, will just remain brown. The color of bromine water will remain brown. But when alkenes react with or are mixed with or shaken with bromine water, the color of bromine water, which is brown, changes to colorless or it is decolorized. Since what's this? Was this cracking was a question for what's this? So I've mixed up the questions. So this is question B, not question D. Okay? This is question B. This is question This is question C. Apologies for that. This is question C. Then question D now, which is the last question, is saying propene is a monomer for making an important plastic. State the name of the polymer it forms. So propene is a monomer. So a polymer will be called polypropene. Okay, polypropene. That will be the polymer. The monomer is propene, the polymer will be polypropene. Okay, that's all to this question. Just to go through again, the structure, draw the structure for formula of alkene. It has a double bond, and the general formula for alkenes is CnH2n, where n doesn't start from 0 or 1, it starts from 2. And the prop means 3. So when you substitute 3, the formula will be C3H6, and the structure formula will have a double bond in between 2 carbon atoms, not throughout, but just between 2 carbon atoms. Then the other one, how they differ, propane and propene, is that propane is, in terms of bond, propane has a single bond, propene has a double bond between its carbon atoms. Then and the other solutions. These are the solutions or answers to grade 12 Science 2022 paper 2 GCE. Thank you so much for watching. Remember to subscribe and like the video.